Hello, grade 11s. So our next lesson is on predicting solubility using your solubility rules. Now in class this would have looked very different, perhaps not been as dry as this might be, so I apologize. If you need to pause, rewind to go over what I've just said, then please do that. Also know that everything that I see, that I post, that you will see on this video is already posted online and ready for you to use. Now you don't need to print any of this, you can use it as an online textbook. Just like you wouldn't copy your whole textbook out, you don't have to copy this out. Of course, if you do want to print it, that is up to you. Okay, so this is how the worksheet looks like online. It's a PDF file in our Google Classroom. So here are the solubility rules. I will make reference to this throughout this video, and here are your questions. Now I'm not going to do every question, but I do want to do maybe one or two from each of these sections. So we'll do a couple from one or two from two, and one or two from three. And that hopefully should be enough. Now, for any future quiz, test, or exam, I don't know how that will look like, but for any future evaluation, you will have access to these solubility rules. Whether you're in class or at home, I would have never asked you, would not ask you to memorize these. You'll always have access to these. All right, so let's get started. I've just copied and pasted the worksheet on page 2 onto our smartboard lesson. All right, so I just put this picture here. I don't intend on you being able to see it. I will go back to the PDF. All right, so question 1. So essentially what we're doing here is we're figuring out, going to begin to learn to figure out how or if something will produce a precipitate. So when two substances react or don't react, is the product going to precipitate out of solution? So will it be soluble or insoluble in an aqueous solution? Let's do A and C. Okay, so we'll focus on A and C. I'll take out a highlighter. Right, we will do A and we'll do C. Right, you will do the other ones. Okay. So it says write the formulas of the following compounds and decide which are soluble in water. So we're just getting started off here. Aluminum has in aluminum chloride, aluminum has a +3 charge. So aluminum has a +3 charge. And we're going to combine that with chlorine, chloride as an ion form, has a -1 charge. You can crisscross these charges like you did in grade 9 and 10, and you'll get the formula for aluminum chloride. So now we're figuring out if this is soluble, and if it is, you would write AQ as a subscript, which means soluble, or you would write solid if it's a solid, which would then precipitate out of solution. Okay, for this question though, I think it's fine if you write either soluble or insoluble. Okay, we will use these subscripts moving forward though. Okay, so aluminum chloride. Now here you go back to your solubility rules. So back to your PDF. And you're going to look for the ions in aluminum chloride. So look for, usually your anion is what you're going to look for. So each of these rules, again, you don't have to memorize these. There are 7 of them. Each of these rules refers mostly to your negative ions, your anion. So look for a rule that says chloride, right? Because we are doing aluminum chloride. So rule number 4 seems to be that. So here it says chloride, and it lists many other ions here. You don't need to consider all of them, but let's just read through it. So chloride, bromide, and iodide, these right now aren't relevant, so just focus on chloride. Chloride ions form compounds that have low solubility with, okay, here are positive ions, silver, lead, mercury, copper. These are the types of charges, so lead 2, mercury 1, copper 1, and thallium positive ions only. So let's try to interpret that rule. Chlorine or chloride ion has low solubility. That means it forms precipitates with only silver, here's silver, lead, right, mercury, copper, and thallium. Aluminum is not on this list, right? That means aluminum is soluble. So we can go back and we can write soluble is AQ. That means it is soluble inside water. It's aqueous, right? In other words, soluble. So we write soluble. Okay, then C. Practice the formula again. Strontium and sulfate. Okay, strontium has a +2 charge. Sulfate has a -2 charge, right? We only need one of each, so we get Sr SO4. Now, is that going to be soluble or insoluble? Right, soluble or insoluble. Let's find the rule that talks about sulfate. So back to our PDF. Rule 5. Look, Rule 5. Sulfate ions form compounds that have low solubility, which means precipitates. So low or insoluble with, okay, strontium. Let's go back. Strontium and sulfate. So sulfate with strontium. So sulfate ions form compounds that have low solubility with calcium, strontium. There we are. Strontium's right here. So it says low solubility, which means precipitates. So sulfate with strontium will form a precipitate. Good. So we know it will form a precipitate, so we can write S for solid. Therefore, the answer to C is insoluble. Right? And you continue the rest of the question the same way, using your solubility rules. Okay, moving on. 2. Now we'll do 2A, and then we'll do, let's pick a different one here. Let's do 3. Okay, how about you pick? Just kidding. All right, we'll do C. All right, we'll do, so I don't forget, highlighter. We'll do C. I don't have answers in front of me. We're kind of working through this with you, and 2A. Okay, get the highlighter out. All right, so write equations to explain the formation of a red precipitate when solutions of, okay, now I'm going to take back that, get that highlighter back. When solutions of iron 3 chloride and sodium hydroxide are mixed. Now here's another keyword, solutions. That means they are aqueous. All right, so if a solution of iron 3 chloride, here's iron, 3 chloride means iron has a +3 charge, and chlorine being halogen has a -1. That means we need 3 of those. That is aqueous because the question says solution, right? Then plus sodium hydroxide. Sodium has a +1 charge. Hydroxide, one of your polyatomics, has a -1 charge, so you only need one of each. And it does say solutions, right, with an S here, which means both of these are soluble. So when these are mixed, they're going to react, it says, and it will react to form a red precipitate. Okay, so it wants us to write a full, the question wants us to write a full equation with, we're going to need these states. So AQ, or S for solid. We know that one is going to be a solid. So what I'd like to do here is, you have to identify that this is what kind of reaction this is to figure out products. If we label this to make it look like a general form of a type of reaction, so if this is A, this is B, so if iron is A, chloride is B, sodium is C, hydroxide is D, this begins to look like the standard form of a double displacement reaction, which means A is not going to be paired up with B anymore. A is going to go with D, and C is going to go with B, which means our products are going to look like this. Fe, and remember, they have to be electrically balanced as well, so the charges have to equal 0. So A is going to go with D, so FeOH. Okay, but Fe, according to the question, has a +3 charge, and hydroxide has -1 charge, so you're going to need to have 3 hydroxides to balance out the +3 of iron. We don't know what those states are, so we're going to leave this part blank for now. With there not being enough room here, what I'm going to do is I'm going to write a plus sign, and I'll continue the next product in this double displacement reaction. Sodium is our positive ion, so we write sodium. That combines with chloride, like this. Right? Sodium has a +1 charge, chloride has a -1 charge, and therefore we only need one of each. Now we also have not written states because we're going to figure that out using our solubility rules. Okay, know that it's not asking you to balance this equation. This is a now complete equation minus the states here. but it's not balanced, right? We will, in our next lesson, get to balancing these equations and why that's important, but for now we don't have to balance it. We're just figuring out which one will form a precipitate. So back to our solubility rules. Let's do iron 3 hydroxide. So, oops, I'll fix that later. I don't really need to. Okay, so we're going to look for iron, I forgot, it was iron 3 hydroxide? Iron 3 hydroxide. So hydroxide, look for the rule that talks about or goes over hydroxide. So scroll through this, 6, rule 6. So it says hydroxide ions form compounds that are soluble only with the positive ions listed in rule 1. Right? This is a bit. This rule is a bit confusing, but just follow along. So it only is soluble with anything listed in rule 1. Okay, well, what is in rule 1? These guys: hydrogen, ammonium, lithium, sodium, potassium, rubidium, cesium, francium. Okay, iron is not in any of these. Right, so it's so far it looks like iron is not soluble, but let's continue reading rule 6 because there was more to it. With positive ions listed in rule 1, and with strontium, barium, radium, and thallium, positive ions only. So iron is not among this list, not among the soluble list. That means if hydroxide combines with any other positive ions, it's going to form a precipitate. So that makes this a solid. That's our state. Sodium chloride is our next compound we have to look at. I think we already did chloride. Chloride is somewhere up here, rule number 4. Chloride, these other two, ions form compounds that have low solubility with only these ions. Notice sodium is not on that list. Here's a shortened version of that rule. Chloride with, notice sodium is not on that list. That means because it's not going to create a precipitate with these ions, it's going to be soluble. So we write AQ. And we're done. That's all there is. So the compound that will then form that red precipitate, according to the question, is iron 3 chloride. Okay, continue the rest of these yourselves. Last question. This says, decide whether a precipitate will form when the following solutions are mixed. Okay, highlight. When this following solution. So here's that magic word, solutions. If a precipitate forms, write an equation for the reaction. Essentially we have to write the full reaction anyways. Whether the reaction or not, we're going to have to end up figuring out if it does. And the only way to do that is to write out the full reaction. So back to our pen. Okay, ammonium sulphide. Right, ammonium is NH4 and it has a positive 1 charge. Sulphide, careful with sulphide. It's not sulfate, it's sulphide. And sulphide or sulfur has a -2 charge. So we're going to need, because ammonium has a +1 charge, we're going to need 2 of these and 1 sulfur. So ammonium sulphide, and because it says solution, we know it's aqueous. So you write AQ plus potassium hydroxide. So KOH, right? Potassium has a +1, hydroxide has a -1. That will react. Now there's not a lot of room here, so I'm going to continue writing in a different color at the bottom. Again, this is A, B, C, D. This looks like the standard form of a double displacement reaction, so that's what we're going to do. That means ammonium and hydroxide are going to come together, ammonium hydroxide. And it will look like this. Ammonium has a +1 charge, hydroxide has a -1 charge, so we only need 1 of each, and that's what that product looks like. I'll leave some space here for this state, and I'll put a plus sign there. Maybe try to fix that. Maybe I made it worse, but this is a plus sign. I made it worse. Oh, eraser's here. Okay. Okay. And our next product is potassium sulphide, right? But we need 2 potassiums because sulphide has a -2 charge. Okay, and we're going to leave space for our state. Good, so ammonium hydroxide. Let's look up hydroxide. Where was our hydroxide? Here it is. Hydroxide. Hydroxide ions form compounds that are soluble only with the positive ions listed in rule 1. There's more to that rule, but let's check out rule 1. So hydroxide, if we see potassium, sorry, not potassium, if we see ammonium, then we know it's soluble in rule 1. Let's go up. Look, there it is, ammonium, soluble. Follow my cursor, soluble. That means AQ. This does not form a precipitate. Ammonium hydroxide is soluble in water. This is not going to be the precipitate. Let's go to sulfide, or the potassium sulfide. Back to the rule. Sulfide, rule 3. I don't think we've done this one. Sulfide ions form soluble compounds only with ions listed in rule 1. Okay, here, look, potassium. And we have potassium sulfide, right? Potassium sulfide. So according to that rule, it says it is soluble. And with group 2 positive ions. Group 2 are your second group in the periodic table, right? And here we are, listed here as well. Okay, but because it already says that from the first rule it is going to be soluble, we can write AQ. So in this case, there is no reaction. When these compounds mix, they don't form anything that is soluble. All that happens here is that you have ions, ammonium hydroxide, potassium, and sulfide ions floating around the aqueous solution, and nothing really happens. So we can write no reaction. I know the question said write the full reaction for anything that does react, but it helps. Well, it's a lot easier to figure out if it reacts, unfortunately, if you have to write or if you write the full reaction. So we've written the full reaction to then determine that it doesn't react. Others, of course, will. So go over these problems yourself. Right, that's your homework. Continue with this. If you have questions, we will meet online virtually. Signing off for now.